Hello students, this is a lecture on acceleration. So we've learned about velocity, where it's the change in distance over time. And now the biggest, I think, understanding is acceleration. So acceleration is a change in velocity. So whether you're slowing down or speeding up, it's called acceleration. So the plane in the picture in the beginning, flying over St. Martin, is said to be accelerating because its velocity is decreasing. So you can say it decelerates, but it's still part of acceleration. So what does that mean? If we're looking at it in terms of equations, we just said it was a change in velocity. So that means we're going to use A for acceleration. It's going to be the change in velocity. We use delta V a lot. That means the change in, so you take your final velocity, subtracting your initial velocity, if there is one. A lot of times the initial is 0, and the total time. So this delta V, delta T means change in or total. Okay? Average acceleration is distinguished from instantaneous acceleration, because it's basically how fast you're going at a very specific instant of time. Okay? And the negative direction in acceleration only means that you're decelerating. You're slowing down in your velocity rather than speeding up. So keep in mind, acceleration points in the same direction still as the change in velocity. It's not always the direction, but if an object slows down, its acceleration is opposite of that of direction of the velocity. Okay, in everyday language it's called deceleration, but in physics it's still acceleration, but the direction is opposite, so you would make it negative. For instance, in this sense, the car, let's say we're driving, 65 miles an hour on the highway, and we're going to start to get off a ramp. So you're going to accelerate, but you're going to accelerate by slowing down. Okay? The arrow, this one says a car can have a positive acceleration and a negative acceleration. So in the first instance, if your acceleration is still positive, that means the car is going to go faster. So the change in velocity is speeding up. So I'm not going off a ramp. I'm either getting into the left lane, or I'm speeding up to pass someone, or I'm just deciding to go faster. So item B is the velocity is going forward, but my acceleration is going negative. That doesn't mean you're turning the car around. That means that you're slowing down. So the change in the velocity is slowing down. So you're getting off the highway, slowing to a stop sign, that sense. So velocity and acceleration, this is another one, they're both vector quantities. So what does that mean? That means they both have magnitude and direction, which means they have a number associated with them, and they're either positive or negative. So an object traveling at constant velocity is going to have 0 acceleration because there's no change in velocity. So if I'm going 65 miles an hour down the highway for an hour, guess what? My acceleration is 0, but I'm still moving. I'm just moving at a constant rate of velocity. So I'm going to talk a little bit about the moving man because that's part of our exercise later. What I want to do is get into the actual equations. Okay, so here's an example. It says a subway train accelerates from rest, that means 0, to 30 kilometers per hour in 20 seconds. Oh, I love how they put kilometers per hour. So we want to find out what the average acceleration is. And so what happens is we have the initial velocities from rest, so it's 0. The final velocity, it was going 30. And we had a time of 20 seconds. So what's our acceleration? So if we looked, the first thing they're saying is that you have to convert kilometers per hour into meters per second, and that is correct. So this would be one of the conversions that you would use. So first they're taking the kilometers, and they're saying there's 1,000 meters in 1 kilometer, so that way we cancel out the kilometer. So you have to multiply the 30 times the 10 to the 3, that's putting it in your scientific notation, and then you're going to divide by 3,600 seconds, because there's 3,600 seconds in 1 hour, and that way we're crossing out the hours. And so now you have the exact same velocity, okay? The 30 kilometers per hour is really 8.33 meters per second. That is the number you're going to use. So the change in velocity, okay, is going to be the 8.33 meters per second minus 0, because it was at rest. Because we know the amount of time, delta t, that's 20 seconds. You can finally solve for A. A would be change in velocity, which is 8.33 minus 0, and the change in time, and they basically said it went for 20 seconds, so you put 20 seconds in there. So your acceleration is 0.417 meters per second squared. That's the biggest sign here. Acceleration is meters per second squared, because change in velocity was meters per second, and now we're dividing it again by time. So it becomes meters per second squared. That is the biggest thing I can tell you that you want to pay attention to, because your problems are now going to start to have velocity numbers, which is in meters per second, and acceleration numbers, which is in meters per second squared. And for you, that is just beginning this journey into our little how we move in physics, you want to pay attention to the units. That will help you figure out which one you're really talking about. And of course, the plus sign in the answer means that it's moving, it's accelerating or speeding up. And it also means the acceleration's in the same direction as the change in velocity. So now it says, suppose at the end of the trip, the train slows down to a stop in 8 seconds from the speed of 30 kilometers per hour. What's the average acceleration? So that means it's going from 30 to 0 in 8 seconds. So we already know that 30 is the 8.33. So now all you're going to do is take the 8.33 minus 0. So you have 0 minus the 8.33, and so it becomes negative 8.33, and you're dividing it by 8 seconds, so it comes out to be minus 1.04 meters per second squared. Notice the minus sign indicates acceleration is to the left, and that's how you would denote it if you're graphing it. Otherwise, it also means it's slowing down. So here is a practice problem that I'm going to do some of the practice problems using the document camera in a minute. Here's some graphing stuff that you can do. Khan Academy, I love. Here's some measurements that you can do with acceleration. Now this is just really quick. In the next chapter, I'm going to tell you, we're going to start to introduce these equations. There's 4 or 5 equations that we're going to start to do to be able to solve some of the problems that we have. Okay, see you in the next video.